Hello guys, and welcome to this 5th episode of our series of DIAMBRA, our launch series of DIAMBRA. So, quick preview before starting. Today we are gonna see really cool stuff. Today we are gonna see a trained AI algorithm playing one of our games, one of our interface games, and so I can't wait to share it with you and to see what it will be able to achieve in our journey. So I think we can start. Get ready. I will need all your help. Please, as usual, interact with the chat, ask questions. Today, I think there will be a lot of things to talk about. And so let's start, and welcome to DIAMBRA. Okay, so here we are, guys. Hello everyone. Hello Curaro. It's great to have you here again. So as I was saying, the preview, today we are gonna have a great step in this adventure. Today we are gonna see an RL algorithm trained to play Dead or Alive++. So just a quick recap of our previous episode. In the previous 4 episodes, we presented all 4 games we interfaced in DIAMBRA, our dueling AI arena. You can find a lot of details in the website, diambra.artificialtwin.com. You see here are listed all 4 games. So Dead or Alive, Street Fighter 3, Tekken Tag Tournament, and Ultimate Mortal Kombat. Hello Colbert Pargolo, it's great to have you here. As I already say please don't hesitate to ask questions if you have during our episode. I'm more than happy to interact with you, and moreover it is of great value for everyone. Quick recap. After presenting our environments, our games, we also run a few episodes with random agent, so random player and a human player. Actually, a very bad human player, that was me. I'm not so good in these games, and actually this is the reason why I look at training an RL algorithm in order to play it for me. Now, why we used random agents? Well, the main reason is that random agents are the baseline, one of the common baselines that are used to evaluate if an RL algorithm is improving, is learning something. So it will be our reference. You can find all previous episodes in YouTube, our channel. Link, you can find the link in the website. You can find also those episodes on Twitch. And so you can go there and take a look at what was the typical performance of a random agent. But today, in order to have, let's say, the clear picture, we are gonna run just few episodes with the random agent, like 3 episodes, just to have an idea of the standard cumulative reward for a random agent. Then we are gonna use the RL trained algorithm. I will tell you more about it later. We are gonna run, I believe, like 10 episodes with it. Hello, Emma, it's great to have you here again. And so we're gonna see the RL algorithm in action for, let's say, about 10 episodes. This will allow us to take a look at how it behaves, how it performs, and so on. Now, a super brief overview of one thing that is always important when taking a look at these episodes, these lives, is the window layout. Window layout recap. This is what you are gonna see during the execution of our environment. And so basically on the left there is an entire section dedicated to representing what is happening in the environment in that moment. And so as you can see, there are a state representation of the game, so frames together with additional info like health of both players. Hello Pedro, great to have you here. So health of both players, sides, meaning that if the agent is on the left or on the right, stage we are playing in, the character, and previous actions. And so this is what basically represents the game state. We are gonna see rewards obtained by the agent and its counterpart. Basically the reward of the opponent, that in the AI versus com mode is the computer. We are gonna see actions sent by the agent to the environment, and also the confidence in these actions taken by the agent. So during our previous episodes, basically what we were using here were confidence derived by the fact that random agents have equal probabilities to take each action, and so these were basically fixed numbers. Today this is gonna change when we use the trained AI algorithm. I will show you how. So hello Mao, buonasera, it's great to have you here. So this is what is represented on the left. On the right, we have at the top, you will see the agent, the game going on, and on the bottom part, you will see a running log of actions taken by the agent. So this is basically all you need to know about the window layout. We will discuss it during gameplay. Now, today we are gonna use Dead or Alive. So Dead or Alive is the first game we presented, and I need to remind you a few things. First of all, Dead or Alive has, of course, 8 different moves, meaning up, left, right, and down, and all intermediate, like up left, up right, down left, down right. So 8 moves plus the no move option, and it adds up to 9. So 9 different options for moves, and then it has 3 different attack buttons: hold, kick, and punch. You can treat, I already explained this during our previous lives, but it is useful to remember that you can represent this action set in different ways. Of course, one important thing to remember is that you also have buttons combination. In particular, for example, you can press punch and kick together, and that's another possibility for attack buttons. So using all these combinations in Dead or Alive, you have as I said, 9 moves. Then you have 3 buttons. You can also take couples of this, so hold plus punch, punch plus kick, hold plus kick, and then all 3 together, so hold, punch, and kick together. This basically makes 7 actions for attack, plus the no action also for those sets, so for that set. So it is basically 9 moves and 8 attacks. This can be treated as it is called multi-discrete action set, meaning that you have 9 possibilities for moves and 8 possibilities for attack options that can be called independently. So you can have like down plus punch at the same time. This is the multi-discrete representation. There are, and this is what we are gonna use. We are gonna use a different representation, in some sense an easier representation from the training point of view. So we are gonna use the discrete action set, meaning that we are gonna use only one set. So moves and attacks will be on the same set. So the agent will be able to choose only one action among this set, either move or attack. These are 2 alternatives. Now you cannot do the same thing. You cannot use both moves and attacks. And also another simplification we are going to use is we are not going to use buttons combinations. So we are going to have 9 moves, let's say 8 moves, plus 3 buttons, hold, punch, and kick, plus 1 no action option. No action, it covers both no move and no attack action. Okay, it's just a no action. Now this adds up to 8 plus 3 plus 1 is equal to 12. We have 12 possible actions. So our agent will be choosing among these 12 actions. Okay. You will see it represented in the previous actions. For example, look at this combination here. The agent is pressing right and down plus 3 buttons together, meaning right R1 plus button 1 and button 2 here. So hold, punch, and kick together. Now this is a combination that will not be possible with our configuration. We will be using only moves or attacks and no button attack actions combination. So this is one important thing to mention. You may be asking why. Well, one reason is that in this configuration you have to choose among only 12 possibilities. And this basically allows you to speed up training, because you have just to learn which one of these 12 actions is the one that you need. You have to search in a smaller space. That's the key. That's the key to lower the training complexity. So is this like a trick? Is it cheating? It is not. And for at least 2 reasons. Where, first of all, as a human, you can decide to play this way. You can decide to play just using or moves or attacks and without using buttons. So in that sense, it's completely fair. I must say that in some sense, it is also an handicap. And this will be key in our gameplay. In fact, in this game, in order to exit from a catch of the opponent, you have to press 3 buttons together. You will see it happening during gameplay. If someone catches you, you can exit that catch only pressing the 3 attack buttons together. So since we are not providing this option, it will be a very bad situation for our agent. Catches will be a very hard thing to escape. Actually, it will be impossible to escape them for the agent, because it has no way to press 3 buttons together, and it has to anticipate these catches in order to avoid falling into them. So this is what I wanted to share with you about action space. Now about another thing to keep in mind is number of stages. In Dead or Alive, in the standard setup, you have 8 stages to finish the game. So you have to go up to the 8th stage, and actually we will be using one and only character, that is Kazumi. We are gonna use Kazumi, and we trained the algorithm on Kazumi, and that's it, no other character. And for Kazumi, the last 2 stages are always the same, against the same opponent. In the 7th stage, we will be facing Ayane, and in the last one, this is common for every character, we will be facing Raido, that is the final boss, let's say. So 8 stages. Another thing to remember is that even if, of course, how far in the game you are able to arrive is a clear indication of how good you are at the game, it is not the main thing to take a look at. I mean that Kuraro is saying that Kazumi was chosen because of her teeth. No, that's not it. Also because there are other characters with this feature in the game. But I selected Kazumi because, you know, it's representative of the game Dead or Alive. It's kind of the image of Dead or Alive itself. And so even if I was saying that even if how far you go into the game, it's a clear indication of how good you are at it. The main value that we have to keep an eye on is the total cumulative reward. That's the number that tells how good the agent is. So we are going to see this now. Let's see, we should start from the random agent. In that way, we are gonna have a baseline of reference to see which level is, let's say, the basic level to overcome, to let's say, surpass with our performance. We will take it as a reference, and we'll see how if our agent will be more performant or not. So let me see. Let's start from random agent. Now, AI versus com mode. Standard things, we activated that game. Difficulty level is 3/4. Let me change the badge. We are in the context of just a sec. We are in the context of AI versus com, and we are gonna use as a start random versus com. So this is our configuration for now. Player 1 will change later when we are gonna use the reinforcement learning agent trained. Now we see here we have number of episodes. Let's use 3 episodes for now in order to evaluate our random agent. Let me choose random agent right here. Okay, so let me see. Okay, it should be already perfect now. Okay, one point that I still have to verify is since the RL agent is of course trained using the GPU, let's hope that it will be able to run with all the streaming infrastructure going on, because of course I tested it, but I wasn't streaming, and so this is the first time I'll be streaming and at the same time running something on the GPU. So finger crossed it will go well, but let's talk about it a little bit more later. Now let's start with the random agent. Let's see if everything goes right. It should start in a few seconds. Just 3 episodes in order to evaluate the performance. Now, an important thing to remember is we are going to use a specific configuration of the game, so difficulty 3 of 4, and that is the standard, let's say, typical configuration and setup for Dead or Alive. Okay, so let me see what's the volume of MAME. I can go a little bit up for now. Okay, so 3 episodes with Kazumi. Let's see. Of course, we are gonna use, as you know, a lot, let's say, not only 1 episode, because it is important to evaluate the performance in a statistically meaningful sense. So we need more than 1 episode to evaluate what's the performance, and of course it is in some sense subject to variance, and so as you will see, performances will not be always on the same level. And so we have, in some sense, to see how they are distributed on all our episodes. But now let's focus on what we are seeing. As you can see in the representation on the left, fixed confidence values. Please take a look also at how the character behaves, meaning that how it select actions. It is clearly, in some sense, a random agent, meaning that it tries to hit the opponent even if when it is pretty far, and so it seems sometimes that is performing strange actions, not meaningful actions, even far away from the opponent. Of course, it's not so, I mean, it's not totally bad as in other games, but it's not good at all. And so you see here we are at the first stage and we are almost done already. A total reward now is about 0. It will be updated soon. It's 0.13. So we are in the range of 0 for now. We'll see on second stage. One important thing to remember is that for Kazumi, based on the experience I saw in using and training the agent in this game, there are few characters that are more tough than others, and in particular big guys, especially the military guy that has a lot of continuous catches, is a problem for Kazumi, and so it is like something critical, especially when it is encountered in the let's say stage around stage 5 or 6. That's kind of a problem. Usually it's hard to, you see also in this case Tina is performing combined catches, and it's hard to escape from them. So we are at stage 2. Our cumulative reward is 0.32, and now we are gone on this round. So it's about 0.04, maybe slightly less, because it has to update. Okay, it's minus 0.64 now. So we are below 0 in this moment as cumulative reward. We have to keep this value in mind. Okay, we see now we are okay, it's the final round, third round on this one, and I believe we are almost there. We'll see. Yeah, that's it. So first episode is gone. We have minus 1.06. Okay, remember this value for the first episode. We had minus 1.06 for our random agent. Ooh, we are almost there, guys. We are almost there, approaching the first run of our RL agent. So please, I will need all your support. The agent will need all our support to perform. Let's say I would like to see a few nice things. Please, when we will be using the random agent, please keep an eye on all moves. Try to capture meaningful moves that you see in the screen, and try to understand if those moves are somehow revealing that there is something that the agent has learned, because let's say it behaves in that way because it is able to know that that's a good idea, that's a good thing. So first stage, and we are done. So 0.2. Emma, great, we are almost there. You see episode 2 on 3 for the random agent, minus 301. That's basically so bad, almost the worst possible in a single stage. Just to a quick refresh, every health bar in a round is basically has a value of 2. So if you win with a perfect, we have a +2 in the cumulative reward. Okay. So let's see, this one, Yan Li, is another problematic character, especially in later stages like 4 or 5, because of course, as you can imagine, stage 4, stage 5 characters are really complex to face. Hello, the Rockerman. It's great to have you here. You arrived just in time. We are almost there. This is the third round with the random agent, and then we are gonna run the RL one. Okay, so we'll see. Now, okay, we are almost there, guys. You see? Okay, that's it. No more random agent. You see another bad reward, minus 2.03. So just wait for the calculation of the mean value, and so we have a reference for the random agent. Let's see, it's almost there, just few seconds, and it will stop soon. Okay, so as you can see here, we have a mean cumulative reward of minus 2.03. Yes, Mauro is saying that random agent is almost shit. Let's say it's pretty bad. Minus 2.03. Okay, now we are ready to move. I'm pretty excited because I saw it already few times. Actually, I kind of staring at it a lot. But before moving to it, let me Curaro, yes. Okay, let me share with you a super quick image that we'll be discussing later. So this is what the RL agent is made of. Okay, I will go through this image later in detail, and we will be discussing it a little bit, but only after our 10 episodes run. So this is the architecture of the policy network. We are gonna use the proximal policy optimization RL algorithm. That is basically one of best and the best starting point when to tackle an RL problem in the end-to-end approach this way. It's a very famous algorithm. It's something that has been applied, for example, by OpenAI on Dota 2. This is the very same algorithm. Of course, the architecture, the training strategy is pretty different. So obviously the infrastructure is not even comparable, but the idea behind everything is the very same. So We are gonna go into details about it later, but just to have an overview, this is what basically links our states made by frames and additional info to actions. So these are the inputs to our policy network, and actions are of course the output. Okay. Hello Andrea, glad to have you here. You are just in time. We are about to run our RL agent on this game, Dead or Alive. So a few other things. I trained this algorithm on my machine. That is a small one. In fact, I'm using a GPU with only 4 GB of RAM. I have a pretty standard CPU, and so I can go into additional details later, especially if you have questions. One typical thing that keep in mind, I used 8 concurrent environments running at the same time. So 8 environments in which making our agent collect experience, and then using this experience collected to train the algorithm with the PPO and in our GPU. As you will see, it will be able, if the streaming, let's say, workload will not mess with it, it will be able to play in real time, meaning that inference speed is compatible with this game FPS, frame per second, let's say, the game speed. And so we will be able to run the algorithm in real time. Now, let me see if I have yes, another thing maybe that is worth mentioning. You will note at the very beginning of our 10 episodes, you will note that there will be like a few seconds of freezing. It is because everything is being loaded to the GPU RAM. And so because it runs with CUDA, and so this is the reason why you will be noticing a first freeze, just few seconds, but that's it. After this freeze, with this first pause, it will go smoothly from there on. Okay, so this is more or less everything I wanted to mention before starting. Now, please keep an eye on everything like action probabilities, how the agent behaves. As I told you, performances are in some sense variable among different episodes, and so we will see if in these 10 different episodes we are gonna run, we are gonna see something interesting in some of them. Of course, as I told you, there are few handicaps, meaning that the fact that we are not using action combination, in particular attack buttons combination, is something that impedes us, our agent, to escape from catches, and so we are not so complete in some sense as an agent. And of course there are improvements that can go and start from where we are now. Okay, let's take another run. Second episode, let's see. So we landed at stage 5 in this one. Okay, remember, yes, exactly, Emma. Sometimes it is able to go backwards and to skip catches and so on and so forth. So these big guys are a problem sometimes, of course, but you know, we have to wait until. And also another thing that I noticed, that you don't have to worry if your health is going down pretty quickly. Sometimes the RL agent is able to recover from a very bad situation. Yes, Emma, you're right. It is the agent going with a backflip and escaping the catch is able to anticipate that it is going to be hit in that way, and so it tries to understand how to avoid the catch. You see, this other guy is another one that uses a lot of catches, and that's a problem when you are not using buttons combination. That's a typical problem when you are facing catches. Okay, another thing to notice is take a look at the action confidence here on the bottom left. You see that now they are varying, they are alternating between moves and attacks in a fashion in which when the opponent is down, it is not attacking, it's just moving, and vice versa. It tries to reach the opponent, move it towards him. Every combo you are seeing here, it's learned from scratch. It's learned from scratch. No, and anything is not a single combo is prescripted, and so it's all combos it is performing are learned in the environment. So this was a perfect. Okay, let's move on. I can assure you we can go further than the 5th stage. So let's hope we will see it this evening. I am, let's say, I have hope that we can reach another stage after the 5th one. Let's see. So this is stage 3. Tina is another problematic character at a lot of continuous catches. It's not so easy. Let's see. I can, let's see. Oh yeah, that was, you see, a bad catch, and then I continued one. In the meantime, let me change the music. Let's go with this one. Okay, so another interesting thing is the time it is taken to move to the other stages. You see, it will be another important reference. Okay, now we are facing Bayman at stage 4. Hopefully it will be easier than before. Let's see. You see, these continuous catches are really a problem, you see, and it's basically impossible to avoid them. Okay, another question. Emma, thank you for this question. Emanuele is asking, will your RL agents be available as additional baseline? I am planning to release the environments pretty soon, and together with them, of course, I would like to add this worked example here, so that you will have this one as a reference, so you can start from it. Okay. Yes. Okay, we were able to beat Bayman. Let's now see this one. This is not so easy to actually, after stage 4, every character, every opponent is pretty hard to face, and so okay, first round gone. First round, we landed it. We are at stage 5. Stage 5, 1 round 0. Let's see. Let's see. Okay. Counter moves are really a problem in this game. You have to catch the right timing. Okay, that now another kick. Come on, come on, come on. Yeah. Oh, yes. Yes. Oh, nice question by Curaro. He's asking, can you try to use another character with the same RL algorithm? And that was one thing that I was going to suggest. Yes. This is something, you know, with this one in hand, you can do a lot of things. You can do a lot of tests, a lot of things that are curious and nice. We will talk about it later. So come on, Kazumi, we are at stage 6. Nice. First round 1. Okay. Let's see. stage 6, then we have the semi-final and the final one. Okay, if we are able to land another round against Hayabusa, let's see. It's not so easy, you know. You can take it for granted also, because there are this kind of combination that are kind of killer ones. Let's see. We have one more round. See you, Belpargolo. See you. Talk online. Come on, Kazumi. Come on. Yes, another one. No, too bad. Okay, let's see. This is second episode, and as you can see, cumulative reward is 8.49. Okay, so I should say it is clearly an agent that has learned something, you know. And let's see. I would like to show you the next semi-final and final round stages. That would be really nice. Let's see. We are at episode 3. The first one is a perfect. Let's see. Now, if you have questions, we can talk about it a little bit, even if I will be like kind of focusing also on the game, because I really would like to together with you to see final reaching it, the final stage. It would be really nice. So 2 perfects for the first stage. Yes, you're right, Curaro. It looks pretty like a natural way of playing. Emma is anticipating another thing. He is asking if I can play as a human against the RL agent. I can do that. No, I can do that. I can also make it play against the random agent too. As you can see, once we have trained agents, the things that you can do are basically endless. Now imagine having agents trained from different research groups and making them fight one against the other. How, I mean, interesting would it be? Different techniques, different approaches, and so I believe there is a lot of value and entertainment in it. So we will see later. Now let's go still with these episodes until I would like to give the agent the chance to face and to go to the later stages. Let's see. Again, Bayman, you see, it's a really complex one, but at least in these first stages, it is quite, let's say, feasible to face and beat it, even if it's not so tricky. You see, another thing to note. Hi, Hedge Crusher, glad to have you. I'm happy to have you here. Okay, so stage 3, 2-0 again. Let's see. One thing to note again is sometimes when the opponent is on the ground and the character is near to it, you see it is able to hit it when it's on the ground with appropriate moves. In particular, a punch or a potential kick are also available in that occasion. And so it is clear that it was able to understand that that move is a good move in that situation. Let's continue. Now we are at stage 4. Let's see how Kazumi behaves. You see, this was a typical move, clearly useful when you are near your opponent and he is down. Okay, so stage 4 is done. We are at 12 plus 12 cumulative reward now. Okay, I must say that reward that is basically usually correspondent to the final stage, let's say the final stage win is around 15 to 16. Okay, Yan Li at stage 5 is pretty complex, I can assure you. Let's see if we are able to land this one. Wait for it, wait for it. No, no. Oh, come on. Okay, nice question by the Rockerman. Do you think you can use this agent with a different difficulty level? For example, I tried it and I expect to have way more difficulties in facing a level 4 COM opponent because the agent is trained on level 3. But we can try also that one. We can try playing against level 4 or train against level 2, for example. Okay, also this one is gone. As you can see now, even if we didn't reach stage 6 as we did before, our reward is higher. You see here it's 11.64. This is what I was saying, meaning the stage you reach is an indication, of course, but it's not the perfect indicator of how well you behaved in that specific episode. Okay, another perfect in stage 1. Let's play with it a little bit and then we can move and test different things. Oh, come on, we are already 1 hour live. The time flies when you are doing these kind of things, and I knew it. Okay, let's see if we are able to reach something in 5 episodes. Okay, not 10. Let's see 5. Maybe, because 10 is too much. You know, because with the random agent, 3 episodes basically are ended pretty soon. In the case of RL Agent Trained, that's not the case. Let's see. Come on, Kazumi. Okay, we are still at stage 2. I will show you. Actually, the playing with a different character is pretty straightforward. Playing at different difficulties is pretty straightforward. Me facing the RL agent is something that is pretty quick because, as you remember, when you have AI versus AI or AI versus human mode, every episode is just a single stage, so a maximum of 3 rounds only. Okay. Let's see. Okay, stage 2 is done. Stage 3, we're gonna have Tina. Let's see now. Okay. Come on, Kazumi, go, go. Bam. Yes. And one is gone. Let me know if you prefer to stop this execution and move to different demonstrations. I saw it end in the game. I can spoil this one. But and so it would be good to share it with you. You know, it's kind of funny. And let's see. Ooh, that was a great combo. Take a look at it. Hi David, it's great to have you here. Oh, come on, Byman, it's always doing this kind of catches. I hate him. You see, if you are not super quick to stand up, it basically catches you even from the ground. It's really complex. Another kick, Kazumi. One, and yes. Okay. So Edge Crusher is admitting that he's not so good at Dead or Alive. Okay, you should see me then. Okay, you have a clear demonstration in our previous episodes. I'm pretty bad at it. I can face the RL agent. You will see me losing basically every round. You see, these catches are basically endless, you know, and that's a problem, totally a problem. And you see, you're basically no way to escape them. And of course, this is clearly a limitation of our algorithm, that is not able to use 3 buttons together to escape from those catches. It's something that of course can be added to the game. Go Kazumi, go, just one hit more, and we are moving to stage 5. 1-1-1, yes. Okay, let's see who is in stage 5. Okay, Bass. Okay, let's hope. Oh, come on. This is another one with catches. Big guy with catches. That's a problem. Yes. 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 Final one. A final one. No. No. Yes. Okay. One is actually the block move is already there. I believe you should be able to learn it from the random play, because block actually the escape move is if you're mentioning sorry, if you're meaning the escape move, it's 3 buttons together. Oh yes, yes, yes. In that case, it would be 13 actions. Yes, and that it's a great idea. It's a good idea. Good idea, Kuraro. This can maybe be something I can restart from here, maybe. Yes, Rockerman, you're totally right. Okay, we are at stage 6 against Yan Li. This is gonna be really hard. Yan Li, it's pretty complex to face. It has few moves that are able to basically take from you about half your health. You see, go, yes, 1 round is gone. Now, one other round and we are at the semi-final. Please, Kazumi, do your job now. Good start, good start. Let's continue. Yes, yes. Okay, okay, come on, another one. Okay, come closer, come closer. Yes. Okay, guys, semi-final. Ayane, it's another complex character. It's another complex one, really complex. I should say even Kuraro, okay, I will answer all your questions in the chat pretty soon. Let me focus now here, because oh, come on, come closer, come closer, come closer. No, another one. Yes, 1 round is done. About training agents with the voice, you're joking, but this is not so a bad idea actually. Let's focus on this one. This Ayane is pretty complex character to face. It has strange moves. Yes, come on, Kazumi, come on. Another one. Go. We are there. No. And using voice, using a different approach, there are a lot of different possibilities, even human-machine teaming, so working together, playing together, it's another kind of interesting stuff. Okay, another round. Kazumi, please, let's go to the final. Come closer. Yes, hit. Yes. Final one. Yes. Okay, we are at the final stage, guys. We are at the final stage. Raido is the final one. Let's see if we are able to finish this game. I'm doing nothing, you know. I just trained the agent. He's doing all by himself. Let's go. Okay, this one is not easy too. Okay, Raido, it's pretty a complex one. And you know, another important stuff to note is that you are facing these characters only once in a while, because you face Raido only when you arrive to the final stage. That's another tricky thing, you know. Okay, come on. Oh, counter move, my dear. Now go. We are one. Okay, we are almost there, guys. Come on, a final hit. Go, Kazumi, final hit. Now. Bam! Okay, ended the game in 4 episodes. We were able to finish the game with a trained RL agent. Nothing done with myself. It was just playing by himself. Guys, we reached our objective now. I won't show you the remaining 6 episodes because, you know, we reached in this one, as I told you, we reached a reward, a final reward of 11.60, and you see, this is not the highest one we got in our 4 episodes. So this means that the reward is a different thing than the stage and completing the game, you know. Now this is important. So game completed, it is showing the final, and thank you Davids, thank you everyone. I'm really glad that we were able to see this one, because you know it's not so easy to predict the behavior. Of course, I was sure it was pretty good. Finishing the game is not something that you can be sure about. Now, okay, we can now start with a few experiments. I know we are already online for 1 hour and 10 minutes almost. Okay, I can kill this process. And let's move to our experiments. So let's use Kazumi with a different character. I must say, let's use Ayane, okay, because it has similar moves. Let's see. Even less than 5, the Rockerman. Because you see, let's use it just for don't worry, I can kill the process. Now let's run this one. So AI versus Com, using Ayane using Ayane as a character, using the knowledge of Kazumi. This is something that I never tried. Okay, so let's see how it goes. I'm pretty curious about it, because let's see. Okay, it is working, because I never tried this one. So let's see. Same difficulty, 3 out of 4 levels. Let's see. Okay, Ayane selected. I think that we are gonna be so bad. Let's see. Go Ayane. Okay, bam. It is using all Kazumi moves, I'm almost sure. And so maybe if moves are pretty similar, it seems we won't be so bad. It appears to be pretty good. First, it was a perfect. Okay, so if the game is made of similar combos, maybe we are good with the Kazumi ones. Even if something that we need to take into account is that our state representation is also made of frames in which, in this case, the character shouldn't be recognizing himself. Yes, Emma, you are right. And let's say as you're suggesting to use a different character, maybe I would use Baiman. That is pretty different. Is also not so nice. And I will use Baiman after this episode's end. Okay. Okay. So you see, I was Curaro, Emma, the Rockerman, Edge Crusher, Davids, Mau, Ibra, Monaldo, you are all suggesting great things, and this is the the value of being live and having a chat together. It's these suggestions, this discussion is pretty informative, pretty full of details, also because for me it's not so simple to understand when something needs to be more clear a little bit. So I would like to share with you just a few pictures of what's the idea behind the policy network together. I will show it to you later. I know we are running a little bit late maybe, but if you have to, let's say, bear with me for a little while more, and then we will see. Okay, we are at stage 3 and we are winning, so that's fine. Let's see. It's something I wasn't expecting, but in the end it sounds reasonable if they are similar in moves and combos. Actually, in fact, the one of the information that we are using is related to player side. So you see, AI side and com side is something that we are passing to our algorithm. Yes, Emma. In some sense, the character knows on which side it is. You know, if it is on the left, if it is on the right. And so, in some sense, the silhouette of the character is not so important, because he knows if it is on the left, on the right. And so, if the convolutional neural net that we are using has a feature structure on the frames, it may be enough to understand the things that you need to use when facing an opponent. The Rockerman is saying that Ayan is one of the strongest characters. I agree with that. It has a super nice set of moves. As you saw in the semi-final, it is able to do a lot of things. Let's see. We are at stage 4 with a good reward of 6.97, but lower than the one that we were able to reach with Kazumi. Let's see. Okay, we are done. Okay, so this reward was 6.8. In some sense, lower than what we were obtaining with Kazumi. Okay, nice question of Curaro. Nice question from Curaro. Let's see how much RAM we are using. Why not? We are live, we can do this kind of stuff. Let me see. So we are using 2 gigabytes of RAM, more or less. Actually is 1.3 by Python, as you can see here. Other RAMs are used by other things. So in particular 400 mega are used by OBS. So 1.3 is used for inference. No, for training and training alone, we are basically at the limit of this GPU. We are almost about 3.9 gigabytes for training, because you are running with the batch size of 8. Here we are using just one item in the batch size and one dimension. And so it's about 3.9 in training. Kazumi has been trained for about 1 month, more or less, starting from scratch. I can show you also charts about training, showing the review, the reward about it. Okay, let's stop now, Ayane. Let's do a single run. Yes, the category of this agent actually Curaro, I would say is not for gigabytes. I would put that restriction on inference, not training. To me, inference is the key point. Training can be scalable. Inference in this sense needs to be fixed since you are running an agent in real time. So Emma is asking, TensorFlow allocates as much RAM as possible during training. I'm not sure about that. It can be right, but I tested it, and the limit is 8 environments on this kind of setup. Oh yes, this is another great question by Emma. So the number of parameters of sides of the saved model file. I cannot show you everything because we are already running late, but we can discuss about these things maybe in a later episode. I will show you details about it. Okay, do you want to try with different characters? Do you want me to try a different difficulty? Please let me know. Let me try Byman in the meanwhile. Let's see how it behaves with Byman. Then, you know, it will be pretty quick to face the RL algorithm myself. It will be pretty quick. It's a nice question by Curaro. Categories should be placed on the model sides or inference in gigabytes in RAM during the real-time operation. Another important question. Yes, we have to think about this. Of course, we will figure these things out as the show goes on. And after receiving feedbacks from you, testing this kind of stuff, it will be hard also to have a common environment that can be shared among all provided models from researchers and hobbyists. Let's see Byman how it behaves. Oh, come on, we were able to perform a catch. Nice one. Okay, perfect. Yes, Curaro is saying we should place some kind of category in order to have fair matches, AI versus AI. You are right, totally right. In some sense, the RAM limitation and also inference time limitation, that's another important thing, because if we want to run in real time, we need to place a limitation, a constraint on the inference time. I believe that those two elements will be a good first step. Marco, he's asking something. If you have the data, it could be great to see a chart showing learning trajectory of the agent. I'm curious to see if it learns at a constant pace or if it has a peak at a certain point, and if so, why? Super cool question, Marco. Thank you very much. I do have charts about it. One problem is that I needed to stop the agent like every 10 million runs, more or less 10, between 5 and 10. So I have splitted charts like every 7 million steps. I will try to show you something. I noticed like a boost around 5 millions and then like a steady increase. Emma is saying something else. Okay, Emma is saying in order to be fair when comparing agents, we should like focus on the model sides. That's a very good point. In some sense, we can think that the model sides is somehow related with RAM and speed of inference, and so in some sense it's kind of directly linked to it, but of course we have to be careful about these aspects. Guys, too many great questions today, a lot of things to answer, and I'm really glad that you have been sharing these things with us. Curaro is asking number of parameters in terms of number of layers or neuron per layers, total number of neurons. Basically, Your model parameters are your matrices, weights, your bias elements, values, these kind of things. And of course, once you have your architecture, they are defined by your architecture. That's it. And so it is of course it of course depends on number of layers, number of neurons, a lot of stuff, and of course it's something that needs to be taken into account. I don't remember the size in terms of number of parameters of this model. I can try to let you know, to figure it out, not in the live, because it would be another thing that takes a lot of time. In the meanwhile, we are seeing Bayman has reached stage 4. It's not performing so bad. It's 8.67 reward for now. And so it appears that even with, let's say, different moves, with characters using different moves, the agent is pretty good. That's fine. It's something that I wasn't expecting. It seems that for this game that's the case. So it should be in some sense simple to transfer this model from Kazumi to other characters in some sense. Another important thing to notice. Now, okay, we are almost done. Okay, we are at stage 5. Nice. Let's see how it goes. I will stop this after the first episode, and I will try one thing, moving Kazumi against difficulty 4, and then I will try to face Kazumi myself, playing against the RL agent. Okay, now we are facing Kazumi at stage 5, and it seems pretty badass. This can be really tricky for the agent, because now it is seeing Kazumi on the screen, and so it may be confused by it. That's a thing. Kuraro is asking a question: is the agent training now? No, it is not training. I can show you the agent training in live. Let's see, I cannot do it today. I can do it in another episode because it takes time and I have to code a little bit, but of course I could. Okay, this run is gone. We reached 8.13 with Bayman. That's not so bad, okay? Okay, so let's try now a single run of Kazumi with the difficulty against a computer opponent of difficulty 4. Let's see what it is able to do. I believe we will lose pretty soon. Okay, let's move to another song. What can we use? This one. Okay, so Kazumi against computer level 4 of 4. Very hard. Marco is asking if there are competition in which our AI will be able to compete. Actually, I don't think so. The best one will be the DIAMBRA tournament. No, first of all, I believe that these games are a little bit dated to have competitions ongoing, but this is the reason why we can use our tournament to face other opponents. So we are at level 4 of 4, the computer opponent. Let's see, you see it is way harder, also stage 1 in some sense. We are not able to perform okay, counter move, good. Now, so moving to stage no, was just the first round, so okay. Okay, again, this kind of catches, that's a bad thing. But a good suggestion by Kuraro. Why not? Let's add only the 3 buttons together so that actions will move from 12 to 13. That's a very good suggestion, and I will do it. I will do it. That's a pretty straightforward improvement of the agent. Thank you for the suggestion. Okay, so we were able to move to stage 2. Yan Li at stage 2. With difficulty 3, it wasn't so difficult to beat him. Let's see now. Nice combo tried by Kazumi, and 1 round is gone. Okay, nice. So, as you can see from the running log here, you see we have either move or attack action. We are using the discrete action set, so no possibility of sending both moves and attack actions. Okay, and again, no buttons combination, so we're using buttons combination is punch plus kick. Kuraro, now we are using Kazumi against a computer of level 4, not level 3. Okay, so instead of using computer at level 3, we are using a more difficult computer at level 4, and seeing what happened. For now, okay, we were able to reach stage 3. We lost the first round. Our reward is 3.09, so it is way lower than in the one that we had against computer at level 3. Still, we are able to do some good stuff. You see, you know, it's one, maybe you now are getting used to the agent, but if you remember how was the random agent was playing, it's pretty clear the difference. You see, the agent here is waiting for the other characters to stand up before hitting. It is waiting, it is moving when the other one is far from it. It is placing good actions at the appropriate time. So with stage 4, with the computer level 4 of 4, we are moving to stage number 4. Let's see, because you know, I hardly think we are gonna reach level 6 or 7. It's pretty difficult with this level of computer opponent. You see, one typical pattern is once you are hit by an opponent, you use that backflip. So Kazumi is basically using every time that thing. Apparently it learned from experience that is a good choice to do that every time he's hit. You see, basically every time it is hit and is on ground, it starts with that move. You see, it's great. Bam. Okay, we are at stage 5, guys. Oh, important thing, I never trained the agent with this difficulty, okay? Another important thing to notice is that I implemented the possibility to press continue when you lose. Few times, a given number of times. In fact, in the game, you have the possibility to hit continue when you are defeated by an opponent, and you can go on the same stage, continue from there. This can be a good strategy, maybe because it would allow you to face over and over an opponent of a high level, like in stage 6 or 5, and so it can be a good idea, a good strategy to continue training. In this case, I never used continue, so basically every time you lost, the agent restarted from the beginning. You saw now it was able to block an attack and counter attack with it, and so we are moving to stage 6. Come on, we defeated Bayman level 4 at stage 5. That was great. Let's see stage 6. I mean, this is the very first episode. Let's see how good the agent is become now. Go. We are almost there. Okay. Oh, perfect. A stage 6 against a computer of level 4. Come on. Incredible. Believe me, it is something that I wasn't expecting at all. So yeah, the training procedure. So at the end, it seems that PPO is performing pretty good, you know? Yeah, that was something that PPO does not need my confirmation. It's a great algorithm. The Rockman is saying something. It will be interesting to see how it is in a lower difficulty level too. If the training time is approximately the same, you can train the agent at the highest difficulty in order to use it. Yes, good idea. The Rockman, the training time is basically the very same, and I tried the agent at lower difficulty levels, and it seemed to me that is what it was pretty good. Okay, we lost a stage 6, but we obtained a reward of 10.12. That is pretty good, now Emma is saying something. Is Kazumi in this run on steroids or what? Yes, you are right. You know, there is variability between runs. Sometimes you use you arrive at a given reward, sometimes you don't. It's variable because, of course, actually it is variable also when the human are playing. Now, okay, we can try different things. If you want, I can face the AI myself. I can face the AI. So AI using Kazumi. I will select my character. I will use, I don't know, maybe Anli. I don't know. I'm good a little. I mean, I'm decent with Kazumi and only Kazumi. But I prefer not to use Kazumi against Kazumi because it may be a little bit messy. Let's see, maybe I can try with Ayane, maybe. Let's see. Since it appears to have similar moves. Let's see. So now I will be facing the AI trained agent, okay? And this is another of those modes that are going to be interesting. So letting the RL algorithm face a human opponent. That is another interesting thing. So almost ready. I will select Ayane. Yeah, that versus Kid, you're right, Marco. Let's select Ayane and let's see. Again, you will have the layout on the left showing you what is happening in real time. Let's see. It's too quick to do that move. Oh, come on. Bam. You see? It's pretty super quick to do that move. No way. As you will see, episodes in these modes, AI versus AI, AI versus human, are pretty quick since an episode is just maximum three rounds. Okay, I won one round. Yes, a student surpassed the teacher. Yes, you're right, Emma. Okay, let's see another set. Oh. That's it. The first one I obtained a -1, and so the agent obtained a +1. Another thing that can be interesting is making this 54 million steps agent facing another different level of the same architecture, meaning like a 20 million steps agent. That is another thing. I cannot do it right now because I have to check how if it is able to run it, because you know the usage of RAM will be like almost twice in this case. and so I prefer to avoid crashes in live. Okay, you know, I know, Rockerman, I'm so bad against the AI. Now, I would like to share with you the training charts. I can show you those charts that are stored in TensorBoard. Basically, training is stored. All info are stored in TensorBoard. Okay, I'm almost there. I can beat him this time. Yes, so I attained a +1. Oh, another great question by Curaro. Let me stop this one and let's move. Let me also stop the music. That is pretty okay for today. Okay, Curaro is asking, did you train the agent always starting as player 1? No, I used a random allocation of player 1 and player 2, so it is able to play on both sides. Of course. Another thing that changed in a random way is the outfit. I used both the first and the second outfits of Kazumi against randomly selected. Okay, so in order to give variability to the agent in that regard. Okay, let me see now if I am able to show you charts about training, and then okay, so TensorBoard, Dead or Alive. The model here is it should be the discrete, no combination, and you see there are 7 different chunks of the entire training. Let's start from the first one. Hopefully our RAM will be enough to allocate, but it seems so. Let me see. Okay, so TensorBoard. Okay, so this is loading. This is the episode reward. Okay, as you see here, it is pretty noisy. We will smooth this out. Let's wait, because I believe it is loading. There are about 10 million steps. It is loading, as you can see. It's 2.4 now. It is loading. In the meantime, while it is loading, I can show you the graphs. This is what represents the entire flow of information from input to output in our model. Let's see. Again, it takes a little while to load everything. This is basically, you see the step from input to output. So from our agent inputs to our agent output. Yes, Emma, this is, you will see it in the other tab, all rewards during training. So basically rewards. No, yeah, you are right. It is only training rewards and not evaluation rewards. It is not stopping the agent to perform evaluation. No. And so, as you, I believe, already know, this is not completely meaningful, because during training you on purpose select actions randomly in order to foster exploration. And so for this reason, your reward is not so meaningful as the one in evaluation mode. Now, inside this one, there is the architecture of the network. It's kind of complex to read from it. I will share a more readable picture soon. Now we are at 9 millions. Okay, now in order to see the trend, let me smooth this thing out. Okay, as you can see, after a startup phase, we are like growing steadily. This is the very first set of 10 million steps. As you can see here, we have a smoothed value of 3.87. I can tell you that in the last chunk, so the 7th chunk, the reward arrives at around 11, a value of 11. Okay, smoothed out. So it is like growing from here up to the end, up to the 57 million steps. Okay, so we are streaming for 1 hour and 41 minutes, quite a long time. I have to show you one more thing, and let me show you this picture, and then we are done, guys. Thank you for being here these hours. So this is the representation of the policy network. On the left we do have, let me clear this thing up. On the left we have our inputs, frames and additional info. On the right we have actions, so what we want the agent to send to the environment, and so we have to link these two things. The policy network is something that, starting from the inputs, decides what actions to take. So what is the architecture behind the RL agent you just saw, the one that was able to finish the game? It is basically this one. We split the input in images, so frames, and additional info, meaning player 1 and player 2 side, player 1 and player 2 health, stage number, and previous actions. Now the first set goes inside a convolutional neural network with a feature extraction, and the other one goes into a fully connected neural network. These outputs are then concatenated and goes in input of another fully connected neural network that basically outputs the action selected. Going inside these blocks, okay, we have for frames images of 256 by 256 and 6 channels, meaning that we are using 6 frames in grayscale, 6 frames that are frames in time, meaning they are the last 6 frames collected and patched together. This set of frames goes inside a convolutional neural network that is built in this way. There are 3 convolutional filters. These sizes that you are seeing here are resulting sizes of the application of the filter that is in between. So after the first convolution you have a 63 times 63 times 32 output. Then you have another convolutional filter. You have 30 by 30 by 64, another convolution that reduces size at 28 by 28 by 64. Then this set of outputs are flattened to obtain about 50,000 elements that are connected with a dense layer and in output, providing in output 512 features. Okay. On the other hand, our input of additional info are 161. It's 1 for the stage, 2 for the health, 2 for the sides, that are 5, and then we have 156 integers for previous actions. Why this number? Well, because first of all we have 12 actions, and I decided to keep last 12 actions in buffer. Okay, so previous action are previous 12 actions. So the entire set adds up to 161 parameters that go inside 2 dense layers and then basically outputting 64 features. These numbers are fused together, concatenated together, so 64 plus 512 adds up to 576 after concatenation here, and this number goes inside the final dense layer that outputs 12 actions. So this dense layer basically links 576 features to those 12 actions, and finally the action to be selected is selected through an argmax. In my case, I used a deterministic way of play, meaning that I was choosing always the action with the highest probability. Okay. You can adopt a different approach, sampling from the set of 12 actions according to the probability outputted by this dense layer. That was not the case in my run, and so this is the action that is sent to the gamepad, so to the environment. This is the full architecture of our policy network. Okay. That's it. That's the how it is built. Of course, there are, believe me, there are a lot of additional details that needs to be taken care of. In particular, number of environment, the batch size, number of steps after gradient updates, discount factor, another important thing, learning rate, clipping factor for the policy network, for the PPO algorithm. So a lot of things to take care of course. These are things that we can discuss in other episodes, and I believe that this is basically it for today. If you have questions, please don't hesitate to share them. If in these few minutes that we have left, we can try to discuss them together. Otherwise, of course, you can reach us through our website. You can reach us through our socials, here on Twitch, on YouTube, on LinkedIn. Thank you, Curaro, for your words. And this live was great. I agree with you, and this is because of also because of you contributing to this. It's really an added value. Thank you, Marco, for your words. I'm really happy, to having been able to share with you the moment in which we were able to finish the game, because it was not to be taken for granted. So guys, that's it for today, and I really, in 2 days, Thursday, we are gonna have the same trial with Street Fighter 3. So I had slightly less time with respect to Doha for Street Fighter, and so let's see what happens. But hopefully we will have good performances too. I hope so. Thank you, everyone. Thank you, Mao. Thank you, the Rockerman, for being here. I really appreciate your presence and your contribution to this live. So, guys, let's continue this way, and thank you again for being here, and it was fun. It was really fun, and see you next time.